Good morning, students. Today we will discuss about Navy Bayes analysis. The outline of this today's class is to understand the concept of probability. We'll understand the concept of Navy Bayes as a classification techniques, how Navy Bayes model work, and what are the use of Navy Bayes techniques in different situations, and what are the advantages and disadvantages of Navy Bayes analysis. Okay, so first thing is we need to discuss about, before discussing that Navy Bayes, we need to understand what is probability. Okay, the probability is defined as the change of something is happening. If something is changed, that one we will call it as a probability. It is defined as the change of something happening. Okay, that probability values you should varies from 0 to 1. Okay, it may be 0 or it may be 1 or it may be 0.5, 0.6, it may be 0.2, whatever it will be. Using the past events, the probability of something is happening in the future can be readily assessed. Okay, so something is already happened. Okay, so the probability of something is happening in the future, we can readily assess it using the past events. Okay, so if you have a lot of experience, then you will predict the future things. Okay, so here every time every year in November month, heavy winter, so then heavy snowfall will be there. So then after that, after a past 10 years, then you can easily predict the future. So from past 10 years, heavy snowfall is there in November month, so it may be in this year also, or in next year also, a lot of snowfall will be there in the November month. So using the past events, the probability of something is happening in the future can be readily accessed. So this Navy Bayes algorithm is the prior probability of an instance belonging to a class in addition to the recent track of the recent track records of the instance belongs to the class. In Navy Bayes algorithm, what we are doing, so here we are using the past data, we are calculating the prior probability, from the prior probability, we will predict the future. Okay, from the prior probability will be taken from the existing data set. So from that, we will predict the future. Okay, that one we will calculate as a Navy Bayes algorithm. Okay, so this Navy Bayes technique is a supervised learning technique that uses probability theory based analysis. Okay, Navy Bayes technique, it is a supervised. We already know that supervised learning technique is nothing but a data has been labeled. Okay, so using that, this is a theory based analysis. It computes the probability of an instance belonging to each one of many target classes. Okay, it computes the probabilities of an instance. Okay, so it belongs to, that instance belongs to one of the many target classes given the prior probabilities of the classification using individual factor. So it means, okay, so it will calculate the prior, from the prior probability, it will calculate the future. Okay, so that is the prior probability of an event is the probability of the event computed before collection of new data. From the existing data, you will calculate the prior probability. Okay, so if you want to collect a new data, so at that time, before collecting a new data, you should calculate the prior probability. So prior probability is nothing but a calculation of a probability before collecting a new data. It means currently existing data, previous data and currently existing data, till that we need to calculate the prior probability. So then what is posterior probability? So posterior probability is in Bayes network. Okay, in a Bayes classification, this is a statistic. It is the revised or updated probability of an event occurring after taking into consideration of new information. Okay, so get the new information. So then after that, you need to calculate the posterior probability by using the prior probability. Okay, so it is used often in classifying text document into multiple predefined categories. That is one applications of Navy Bayes. So here what we are doing, we are classifying the text document into one of the multiple predefined categories. Okay, so here I am taking one simple example of data. So then you will easily understand what is Navy Bayes classifier. Okay, so here suppose a saloon needs to predict the service required by the incoming customer. Okay, a saloon needs to predict the service required by the customer. So the customer wants whether haircut or manicure or pedicure, whatever it may be. Okay, so we need to predict future. So for that future service, so for that we are using the existing data. Okay, so we are representing haircut is R. Okay, manicure and pedicure will be M. Okay, so here the value to be predicted is whether it will be haircut or it will be manicure or a pedicure. Okay, so here number of classes K is 2. So that is haircut or a pedicure, pedicure. So first step, what we compute prior probability. Prior probability is nothing but calculating the probability before collecting a new data. Okay, so this data is gathered for last 1 year. Okay, that already data is gathered, so that from past 1 year the data has been gathered. Okay, so here we have for the last 1 year 2500 customers for R. Okay, for haircut, and 1500 customers for manicure and pedicure. Okay, total 4000 data is there. In that 2500 data, to 4000 customers are attended for past 1 year, and in the 2005 customers have taken haircut, and 1500 members have taken the manicure and pedicure. Total number of customers are 4000. Then now calculate the prior probability. Okay, calculate the prior probability. How we will calculate the prior probability? So prior probability for the next customer to be for R, for haircut. So haircut is 2500 members. For the past 1 year, 2500 members have attended. Okay, so the total number of customers are 2500 plus 1500 manicure pedicure, total 4000 customers. Okay, so it means haircut customer is 2500 divided by total customers is 4000. It will be 5/8. Okay, so then like that prior probability of manicure and pedicure. So prior probability of next customer to be for manicure and pedicure, it may be, so the 1500 customers for manicure and pedicure divided by total number of customers, 3/8. I will get a 3/8. Based on this information, so we will predict, so next customer would likely to be R. Based on this probability 5/8. Okay, so it will be next customer would be like to be haircut. Okay, so based on that value, so we will get a okay. So here both are 8. So here he is having R is having highest value when you compare to manicure and pedicure. So therefore the next customer would likely to be R. Okay, so using prior probability. Okay, so next one more concept is there. So prior probability is calculated before collecting a new data, and before collecting a new data, that is from past 1 year. Okay, so that one we are calculating the probability, that one we will collect as a prior probability. So next one is recent probability. Okay, so another way to predict the service required by the next customer is look at the most recent data. Okay, so most recent data. So here we are taking the most recent data is nothing but a last 5 customers, what they have taken service. Okay, suppose the last 5 customers were the service are haircut, manicure, pedicure, haircut, manicure, pedicure. Okay, so this is the sequence. So in that 2 members are taken haircut and 3 members are taken manicure and pedicure. So then recent probability of R, that is haircut is 2 members divided by 5, that is 0.25. Okay, so then recent probability of manicure and pedicure. So here manicure pedicure 3 is there, 3 members are taken, 3 divided by total number of customers are 5, so it will be 6. Based on this information, the next customer would be manicure and pedicure. Okay, based on recent probability. Based on prior probability, it will be haircut. Okay, so for past 1 year, this is the recent 5 data. So now we have prior probability and you have the recent probability. You got the difference now. Prior probability is past data and recent probability is recent data, most recent data. Okay, so now we will have Navy Bayes posterior probability. Okay, so how we will calculate the posterior probability? Navy Bayes. Navy Bayes is nothing but it is a posterior probability. Okay, this posterior Navy Bayes posterior probability will be, okay, so Navy Bayes posterior probability for a class computed is by multiplying the prior probability and the recent probability. Naive Bayes posterior probability for a class computed is by multiplying the prior probability and recent probability. Prior probability is nothing but a past data into recent data. That is probability of past data and probability of recent data. That one we are correcting. Maybe by posterior probability of PR for haircut, it will be, we have got 5 by 8. This is prior probability, and 2 by 5. It will be the recent probability. When I multiply these things, I will get 10 by 40. It will be 0.25. Like that, we are calculating the posterior probability of P of M, that is the manicure and pedicure. So here 3 by 8 is nothing but a prior probability, and 3 by 5 is nothing but a posterior probability. It will be 9 by 40, it will be 0.225. So here, since that posterior probability of haircut is greater than manicure and pedicure, posterior manicure pedicure, therefore there is a great probability of next customer would be the R. Okay, so based on that data, okay, so based on that, there is a great probability of next customer would be R because of this posterior probability, and so because of recent probability and prior probability, we have calculated the Navy Bayes. The Navy Bayes will be predicting that next customer would be the R. Okay, so we have calculated, this is a Navy Bayes model. So the posterior probability belongs to a class K is calculated as a function of prior probability and the current likelihood value. So prior probability is nothing but a past data. Okay, whatever I have taken an example, that is past data probability, and current likelihood value is nothing but a recent probability. So that one we have given. So P by A of B. So posterior probability of Navy Bayes classification, it will be prior probability of A, okay, P of A, and it will be most likelihood. Current probability is nothing but P of B by A divided by P of B is nothing but an evidence. Whatever we are taking the total values, that will be the evidence. Okay, so this one will represent in the Navy Bayes model based on the posterior prior probability into recent probability. Okay, so then what are the advantages and disadvantages of Navy Bayes classifier? Navy Bayes logic is a simple, so it is Navy Bayes posterior probability computation. So it is very simple. So here, if you calculate the prior probability and the recent probability, easily you make it the posterior probability. This conditional probability can be computed for a discrete data. Okay, so if you have a discrete data, so at that time you need to calculate the conditional probability. Okay, so then Navy Bayes assume that all the futures are independent and most instances that work offline. Okay, the futures are independent. The Navy Bayes assumes that all futures are independent for most instances that work offline. Okay, so the limitation of NB posterior probability computations are good for comparison and classification. So it is posterior probability computations are good for comparison and classification. For that, it is a good. For other things, it may be some limitations. But probability values are not good even for event happening. Okay, for comparison and classification, the posterior probability are good. But when the some event is happening, for that you need to predict. So at that time, it may have not good enough. Okay, these are advantages and disadvantages. Okay, so now we will see the program 5. So based on this Navy Bayes classifier. Okay, so here we will have a write a program to implement the Navy Bayes classifier for a sample training data. Okay, for a sample training data set stored as CSV file, compute the accuracy of the classifier considering the few test data sets. Okay, so here we have it, we need to take a CSV file. We will apply the Navy Bayes classifier, and we will calculate the how it will classify accuracy of the classifier. We need to find the accuracy of the classifier. Okay, that is Navy Bayes classifier. Okay, so here we are taking the data set. Okay, so CSV file data. Here we are taking the data set to classify how that Navy Bayes will classify, predict the future. Okay, predict the future based on that recent and posterior data, past data probability and recent probability. So how we will predict the future incorrect. So for that we are taking this 5 PIMA Indian diabetics. So this is the most popular this data set they have taken. Okay, we have taken. So this data set is originally from the National Institute of Diabetics and Digestive and Kidney Disease. From that they are taking this. We are taking this data set. Okay, the objective of the data set is to diagnostically predict whether or not a patient has a diabetes based on certain diagnostic measurements, okay, that are included in this data set. That may be blood, okay, blood pressure, heart, the BMI, insulin level, pregnancy, all those things they have considered, male or female. Okay, several constraints were placed on the selection of these instances from a larger database. Okay, in particular, all patients are females. For example, they are taking, so they are all patients are females at least 20 years old of Pima Indian heritage. So they are taking the females. They are having more than 21 age old. Okay, so this data set consists of several medical predictors variables, one target variable, that is outcome. So here n number of attributes are there and one features are there and one target, whether a person is having diabetics or not. Okay, so that is the target value. That is the outcome, whether that person is having diabetic or not. So here what we are doing in Bayse this program, so we are training the model. Okay, after that we are predicting how much, we are predicting whether based on that feature we are predicting whether that person is having diabetic or not. So how accurate based on that, so what is the accuracy, how much that our model will predicting properly. Okay, so predictor variables includes the number of pregnancies, like pregnancies the patient has had, their BMI, insulin level, age. So n number of parameters they have included in this variables, predictive variables. So here we need to calculate the accuracy. Okay, so in that program we are telling that need to calculate the accuracy. How accuracy will be calculated? What is the accuracy? Accuracy is nothing but it is the number of correct predictions. Okay, it is the number of correct predictions divided by made. Okay, it is the correct number of predictions made divided by total number of predictions made. Okay, so number of correct prediction made divided by total number of predictions made multiplied by 100. Okay, to turn into a percent. That is, accuracy is nothing but number of features classified correctly divided by number of features. Okay, so here, so this one we will have, how that this one we will have a we call it as a confusion matrix. Okay, so in that, see here, these are the actual values and these are the predicted values. So we may predict whether yes or no, whether particular person is diabetic or not. Okay, so here, for example, we are taking so positive. So here predicted, these are the predicted values, these are the actual values. So I am taking one example. Okay, so female, I will take one example. So female got pregnant. So here actually is pregnant, female pregnant. Okay, so here predicted is for pregnant, female is pregnant. So it means actually is pregnant and predicted is also pregnant. So it means it will be true positive. Okay, so true positive. So here predicted is false and actually is positive. Okay, so I am predicting male is pregnant. Okay, so here male is pregnant, so it means male is pregnant, it means, so here pregnant is positive but male is false. Pregnant is positive, male is false, like that. Okay, so here another, if predicted is negative but actual is also negative. Okay, so here what we are doing, so here actually is female not pregnant. Okay, so female is not pregnant, so here it will be female is not pregnant. So female is true, pregnant is negative. Okay, male is not pregnant, so male is also false. Okay, negative is not pregnant is also negative. So it means that is male is false and this one is also negative. Okay, so accuracy will be calculated true positive plus true negative divided by all samples. True positive divided by true negative divided by all samples. Like that we will calculate the accuracy. Okay, so now I will go for the program. Okay, this is the program what we have. So here I will start from the main. I will start from the main. Okay, so here the file name is 5pima Indian diabetic data.csv. Okay, so this is the file name. So this CSV file is stored in the same folder. Okay, so I have taken this file name. Okay, it will be stored in this file name. Okay, and here I am splitting the data set into, that is split ratio is 0.67. So it means 2 by 3 will be the training data and 0.33 will be 1 by 3 will be the test data. Okay, so 0.67 means 100 minus 0.67, it will be 0.33. Okay, so it means 67% will be the training data. The split ratio 2 by 3 and 1 by 3. So that is the split ratio. So then here data set we are loading the CSV file. Okay, so load CSV. So for that we are the file name, in that file name we have a 5bima Indian diabetic.csv is there. So that one we are loading to data set. Okay, and here what we are doing, so we are splitting that data set into training set and test set. Split a data set into, so this data set comma split ratio 0.67. Now it will be splitting into training data will be training data will be 0.67% and test data will be 0.33%. It will be, if we have 100 data sets, it will be split into 67 and test data will be 33. Okay, so that one we are doing here. Then after that we are printing this training data and test data. Okay, we are splitting that length of test data and length of training data and length of test data we are printing here. Then after that I am calling the summarize by class. So and by passing the training data to train the model, I am passing this training data. Okay, so I will come to summarize by class. Okay, in that in this function what we are is we are predicting we are applying the navy Bayes classifier. At least we are training the data. Okay, so summarize by class. So here we are the data set has been passed. Okay, so here separate by class. So in one more function we have separate by class. So it means we are just splitting the training data and so we are splitting the features and target value. Okay, separate by class data set. So when I come to separate by class, okay, when I come to separate by class, so here what we are doing is, so here we are splitting the training data and test data. For that we are using integer ilog function. So same thing we are doing by defining the function. So here for that one we are doing, so we are separating the test data and training data by separate by class. Okay, for each for I in range of length. So here we are taking the first length of the data set, and after that we are removing the last column, and others will be appending to that particular separated vectors we are appending at the end. Okay, so here we are in that separate by class we are doing the separating the training data and test data. Okay, so then after that, okay, separate by class, after that what I am doing, I summarize it for class. Okay, so we need to summarize. It means we need to calculate the mean. To calculate the probability, we need mean and other things. So that one standard deviation, we are doing that one in this for each summary of class values. So here I am calling the summarize function. When I by passing the instance, each instance for that we are coming. So here when I come to summarize, so here in this summarize, I am calculating mean of a particular attribute, standard deviation attribute. Okay, I'm calculating mean, standard deviation for attributes in the data set. Okay, for attribute in the data set. So I am calculating mean and standard deviation. Okay, so then after that I am getting all those values in a make it in a zip. Okay, so then I am doing the calculating all those things. So then after that return summaries. Okay, so after that, okay, summarize class, then after that I am calculating the mean and okay, so calculating mean and standard deviation. After that I will I need to calculate the probabilities. Okay, so calculate the probabilities by passing the value of particular value x, mean and standard deviation. Okay, so first we have calculated mean and mean and standard deviation we have calculated. So then after that we are passing those things into mean and standard deviation here. Okay, so here we have to calculate the standard deviation. So we will have this formula. Okay, so mathematical formula here we are applying. Then after that we are calculating the standard deviation. Okay, once we calculate the standard deviation, next we will have a calculate the class probabilities. Okay, so here a particular attribute we are calculating. Right? So here we are calculating for whole class. Okay, so by passing mean and standard deviation. Okay, for class value, class summaries. Okay, this summaries is nothing but so here we are we are separating that class values. Okay, so that summaries we are calculating here by calculating the probability of by passing the x, mean and standard deviation. Okay, so here we are calculating for whole data set. So then after that we are predicting. Okay, when I come to predict, okay, so here after that summaries I have done, after that I need to calculate the prediction, get predictions, that is how much we predicted correctly. Okay, and we are testing. Okay, so get prediction and test, summaries and test. So when I come to get predictions, so here result comma, so here for each length of test data, so here we are testing the data. Okay, so by passing the test data, so here what we are doing, predict summaries comma test of I. So here summaries we already know the features are taken. Okay, and test set of but one test set we are taking, and here we are doing predictor. How we will predict? So for that we are we have a that Navy Bayse classifier, whatever I have discussed that formula na. So that formula we have the prior probability and posterior probability have been done here. Okay, so then after that how we will get the accuracy? Okay, so here accuracy is nothing but it is accuracy is nothing but it is the how much we predict properly. Okay, how much we predict properly divided by total number of future. So that one we are doing. So here we are calculating the accuracy. Okay, by test data and predictions. So here we are correct predictions, that is correct divided by float of length of test data. Okay, so correct divided by float of length of test data. Okay, so length of the test data, correct predictions divided by total length of the test data multiplied by 100. So I will get a accuracy. Okay, so once I get that accuracy, I will printing that accuracy. Okay, so I will show the execution of this program. Same program I have typed here. Okay, if I execute this program, okay, so here 760 rows are there. So here this is the result. Okay, 760 rows are there. So in that we are splitting that one into training is 514 data and test data will be 254. So it means 67% will be the training data and 33% will be the testing data. Then accuracy is nothing but 0.3939700. So this much of accuracy we are getting for this. Okay, so that much that it is correctly predicting. Okay, so this much we are getting the accuracy. Okay, so like that, this Navy Bayse classifier will predict. So now I will discuss one more program based on this Navy Bayse classifier. Okay, this is the 7th program. So here, so write a program to construct a Bayes network considering the medical data. Okay, so here they are using medical data. Use the model to demonstrate the diagnosis of heart disease patients using standard heart disease dataset. Okay, you can use Java or Python ML libraries. So you can, here in 5th program we are not using any libraries. Okay, so here they are, we can use a library, inbuilt library. You can use your API or classes you can use in this 7th program. Okay, so here we are using a Bayse P1. This is the, in that we have a Navy Bayse model package. Okay, so here we are using NumPy, and here we have a CSV package we are using, and here one more we have a Coloroma. Okay, so the Coloroma, so this Coloroma provides a simple cross-platform API to print colored terminal text from Python application. So for that we are using this Coloroma. From that we are using init. So this init method is called when we initialize the attribute values. Okay, whenever we want to initialize the attributes, so at that time we will use this init function. Okay, so and here to make a style back, all those things we are using. So here they are taking, so in this we are predict heart disease. Okay, so based on these parameters, we need to predict whether the particular person will get a heart disease or not. Okay, so here we have an attributes age, num, gender, family history, diet and lifestyle, and cholesterol and heart disease. So from that init, so this init method is called when we initialize the attribute is released. Okay, whenever attributes initialization, at that time we need this init. Okay, so here I am taking, so in that age, so age will be super senior. So in that CSV file also same values are there. Okay, same attributes are there. Okay, so age num, it will be super senior citizen 0, senior citizen it will be 1, middle age 2, youth will be 3. Okay, and teen age will be 4. So here 4 varieties of age is there: super senior, senior, middle age, youth, and teen. Okay, 5 values are there. And gender number, gender it will be male or female. Male for 0, female for 1. Family history, whether the heart disease are there, yes. If it is yes, 0, no is 1. Okay, diet, whether is doing diet, high is 0, medium is 1, low is 2. Lifestyle, if he is athletic 0, active is 1, moderate is 2, sedentary 3. Okay, cholesterol will be high is 0, borderline is 1, normal 2. And heart disease, it will be yes or no. So these are the attributes we are taking, whether already particular person have heart disease or not, yes or no. Okay, so these are the values, these are the attributes we are taking, and from that these are the values we are taking. So first, okay, from this, okay, you need to initialize the, first we need to train the model. After that we need to predict the model based on the values given by a user. Okay, so here first we need to read the CSV file. So this heart disease data CSV, into same attributes values are there. We are reading that one. So we are creating the reader object csv.reader. Okay, so we are read the CSV file, that one will be stored in line. Okay, and we will list that lines, we will list the data. Okay, and we will store that one into data set. Okay, so here for X in data set, we will append whatever the values we have, we will append A of 0, age number, and gender, that is the 0th column, first future, 0th future, first future, second future, diet denum third future, like that we are assigning that. Okay, then we are converting that data into an array. Okay, and the length of the array will be stored in n. Okay, so now we will assign the group assignment probabilities. So here this Dirichlet. Okay, so this Dirichlet function, so this is inbuilt in Navy Bayse. Dirichlet is a scientist. He developed a Navy Bayse classifier. This is an inbuilt API. Here we are using to build the calculating Navy Bayse classifier. So here what we have written a program in that functions for Navy Bayse classifier for prediction for calculate standard way of calculating the probability. So here everything is inbuilt. Okay, just you need to pass the values. That's all. Okay, so using this is the Navy Bayse classifier. Okay, so here for age. Okay, so we are predicting that prior probability, posterior probability, recent probability, all those things. So here 0.1 into NP dot. So how many variables values are there? For age num it will be 5 values. Okay, so NP dot once it will be 5 values. So that group assignment, like that. Then this one is the categorical. The categoricals are, these are the categories are one type of Panda data types. Categorical variables are in statics. Okay, it may not values doesn't change. Okay, so categorical variables taken in a limited and usually fixed and number of possible values. So it may be gender or a social class, blood type. These are nothing but the static variables. That categorical variables. NP.1. What is that? NP.1 gives new array with the shape and size. Okay, so NP.1 it will be gives the new shape and size for the array. Okay, this one converted it into a categorical variable. Okay, so by calculating all those Navy Bayse, applying the Navy Bayse, we are converting into a categorical variable and we are giving a shape. Okay, so then after that we are calculating it, and so here age dot observe it will put it into the 0th value column. Okay, so like that we will calculate for the gender. Okay, so here same thing, we will apply the Navy Bayse classifier and the number of variables. So it will be values are male or female. Okay, it will be 2. Okay, so then after that we are making a categorical variable. Okay, and I am observing and we are putting in the first column. Like that family history also we are doing same thing, and the diet also we are doing same thing. Where number of values it will be 2. For this one it will be 3. Okay, so then P dot lifestyle. Okay, for lifestyle also we are doing. Okay, and we are storing in the 4th column. Okay, then for cholesterol also same thing we are doing. So number of values is 3 and it will be putting in 5th column. Okay, so we are done. Then finally we are predicting the heart disease. Okay, so for finally we are predicting heart disease. Okay, so that is same thing, applying the Navy Bayse classifier and we are passing the values. So what are the values for each one? 5, 2, 2, 3, 4, 3. So values of that first one. Okay, so that is senior citizen. Okay, middle class, teenage. Okay, so then this is the second one is that is gender, male or female, family history. So these are the values what we have. So then after that, here we are applying that multi-mixture model. Okay, to calculate the we will predict the we will predict that final thing, predict the final whether that person is having heart heart disease or not. Okay, that one will be stored in this heart disease. Okay, so in this variable we are updating that heart disease. So now we will print the whether that particular person will have a. So here we are taking the values where I enter the input age. We are taking the values of each one. After that we are predicting. We are taking the values. So here we are predicting the thing. So here finally we are putting that one. This multi-mixture model. Okay, so here whatever based on those values we are printing those the BP nodes category that P heart disease. This is the output of whether a particular person is having heart disease or not. So that one we are printing. That one we have calculated here. Okay, so when I execute this one. Okay, so it will ask enter a age, so super citizen, senior citizen, middle age, or youth, or teen. So I will tell that this super senior citizen, it will be the value will be the, okay, so value will be the 0. Okay, I have entered value will be the 0. Okay, so then enter the gender. So gender is female. Super citizen, no, female. Okay, and enter the family history. So family history, diabetic, heart disease is there. Okay, fine. Then enter the diet. So diet is in medium. Okay. So then whether he is athletic, moderate, sedentary. Okay, you can give, I am giving a moderate. Okay. So then cholesterol. So cholesterol will be the high, borderline, or normal. I will put borderline. Okay. So here the probability of heart disease is 50%, 0.5. Okay. The probability of the heart disease is 50%. So like that, I will give one more. Okay, I will give one more. Okay. So enter the age, youth. I will give teen. Okay. So then after that, gender, male. Then family history, it will be no. Then diet is 0. Okay. So moderate code. Yeah, I will give the lifestyle moderator. Okay. Cholesterol will be the normal. Okay. For this probability will be the 0.5%. So like that, you can give varieties of you can give varieties of different values. So based on that, it will predict the values. Okay, so based on it will predict the values. So here we have, we are using almost all inbuilt API for this data set. Okay, this is the 7th program.